Hello everyone, welcome to my YouTube channel CodeSpace. Today we are going to learn about linked list in C Sharp. First of all, we will first cover the basic understanding of linked list, how it is created, what is it, and why we need such an structure. Okay, let's start with the definition of linked list. Linked list is a data structure where elements are stored in a sequence of nodes, and each node contains both data and a reference, that is a pointer to the next node in the list. So let's understand with the help of a diagram what is a linked list and how it looks like. So linked list means a list of connected nodes where each node is presented with two information. So let me try to create a diagram. Okay, so this is particularly a node where the first information is data, and this is basically a pointer to the next node if it is available or not. So this is the next, and suppose we have another node. This will be the data for this node, and again this will be the pointer which will point to the next node, or it will point to null in case there is no other element. Okay, so this complete structure is treated as a node. Okay, what is memory allocation? Memory allocation means when you create a new node, that is this particular node, when you create it, the memory is allocated on the heap for this particular node. The memory of the data is reserved along with the memory for the reference, that is the next point. Okay, linking nodes. To form the linked list, you set the next reference of one node to point to the next node. So basically this is nothing but the link between two nodes, say node 1 and node 2. So this link is just the connection between these two nodes. Head pointer. So in most linked list there is always the first node which is known as the head. So in our case the n1 will be treated as a head node. It means whenever we need to traverse or check the list of a linked list, then we have to start from the head, that is the starting point is head of a linked list. What is a dynamic sizing? Linked list can be dynamically grow or shrink because each node allocates memory as needed. This is in contrast to arrays which have a fixed size, because we are keep growing our node dynamically without even creating any fixed size. Only the single node is treated as a fixed size. Other than that, it will be a dynamic. That means we can create as many nodes as possible based on the available memory in the system. Let's try to understand how nodes or linked list is stored in the memory. Suppose we have a linked list like this, and it has like 4 nodes in our example, like n1, n2, n3 and n4, and each of them are connected with link between them. So our head belongs to the node n1. So the nodes are not necessarily need to store contiguously. That means n1 can be stored here, n2 can be stored here, n3 can be stored here, or n4 can be stored here. It depends on the availability of the memory blocks which can store a particular node. So it is very different from the arrays concept, which require to store information in a contiguous format. But in case of linked list, it is not required. So in case we have to connect these nodes. Then n1 have the address of node n2, that is this one here, the L1 link, L2 and L3, say the link between n1 and n2 is L1 and n2 and L3 is L2 and so on. So this is L1 and now this is L2, and similarly we can connect this as L3. So this is how the node is stored in the RAM, and it is more efficient compared to the array, because in case we do not have sufficient memory blocks available, then arrays won't be able to store in the RAM. But in case of linked list, we can store in the far memory block locations for the linked list. So it is very efficient. So I hope the memory efficiency and allocation of node in the memory is clear now. Let's talk about the performance trade-offs. Linked lists are efficient in insertion and deletion at the beginning or middle of the list because you only need to adjust the references. However, they are less efficient for random access because we need to traverse from the head of the node going to the nth node that we want to looking for. Suppose, so this is one node and this is another node. Now we need to insert a node between these two nodes. So what we need to do, simply we need to change the reference from this n1 node to n3, and n3 node reference will be moved to this one, and we can remove this particular node, so it will be removed. So that's how the simple insertion is performed, and similarly we can do deletion by removing these 2 points and connecting these nodes. It's that simple. But in case of traverse, we need to start with the head of the node and then go up to the complete node or where we want to search for this. So this is the performance trade-off. Last one is the garbage collection. In C#, .NET garbage collector automatically reclaims the memory for nodes that are no longer reachable. Means when we have to deallocate a memory in the C#, we do not have to take care of that. .NET garbage collector will do it automatically whenever that particular node is no longer required. So in case of deletion, this particular node is not required, then it will be claimed by .NET garbage collector. So I hope the linked list basic picture is clear now. I hope you are able to learn something new from this. If you learned something, then please like and subscribe and share the video. Till then, happy learning.